Hola, hola, hola a todos. Qué lástima que no estamos juntos allá en Panamá, pero por lo menos tenemos una comunidad en la red de Zoom, en el mundo Zoom. Tenemos el gran placer hoy de tener con nosotros un gran reportero de Estados Unidos, Dominic Gates, que ganó el premio Pulitzer este año por su investigación de las fallas en el aeronave BOEING 737 MAX. Y lo que él descubrió fue algo que realmente sorprendió a todo el mundo de aviación. Reveló una falla en el sistema en el aeronave que era nuevo antes de que anunció la falla la compañía Boeing y antes del segundo choque de avión. Entonces él nos va a explicar cómo un periodista de investigación, un periodista que realmente no se especializa en investigación, sino cubre el mundo de aviación, descubrió algo que realmente nadie más sabía, salvo los expertos que no quería revelar lo que estaba pasando con la aeronave. Entonces él nos va a explicar eso y hoy va a presentar en inglés. Dominic Gates es originario de Irlanda y él empezó como profesor de matemática. Entonces es una de las razones por la cual creo que no tiene ningún problema manejar información complicada. Y empezó a ser periodista por una historia de amor. Encontró a su esposa en África cuando estaba trabajando en Zimbabue con ella. Ella era periodista y la siguió a Seattle, donde desde entonces tiene una carrera muy exitosa también como periodista, cubriendo Boeing, cubriendo aviación desde hace 18 años en la ciudad de Seattle. Y él ganó el premio Pulitzer justo con sus compañeros en el Seattle Times, que fueran miembros del equipo de investigación. Pero él nos va a empezar a explicar cómo descubrió algo realmente sorprendente en su trabajo. Y al final, ustedes pueden compartir sus preguntas con él y me lo pueden mandar sus preguntas por chat en español y yo lo puedo hacer la traducción al final. Y ahora voy a dejar la palabra a Dominic, que va a hablar en inglés, pero despacito para que todos nos puedan seguir su presentación muy interesante. Dominic, thank you.
Well, hello everyone, and thank you very much for inviting me to speak to you, especially since I don't speak Spanish. I hope I can be of some benefit to you. I'm going to talk about the investigation that followed the crash of the Boeing 737 MAX, first of all in Indonesia, and then less than 5 months later in Ethiopia. 346 people were killed. And we did an intensive investigation competing against all the national papers in the United States and even internationally. But before I talk about the MAX accident, I just like, some of you may at some stage want to cover air accidents in some way. And so I just want to reference a database that you can look up for past accidents. I'm going to share my screen 2 or 3 times during this presentation, and I'm going to share the screen right now. And you see here, this will be made available to you afterwards, but this is just a list of aviation safety and accident databases. And if I click on this one, this is probably the best one, the second one from the top. It's a US database. There are others based in Switzerland and elsewhere. But if I click on this one, it will bring me to a page, and I will show you now. No, I didn't realize I have to, 1 second. Right, it brings you to this page. And this is a historical database of all the aviation accidents, not just fatal ones. I'm going to show you something that you might remember. 2006. This is a list of all the accidents that happened in 2006 around the world.
Dominic, we're still seeing the word filed. Can you put the other one on top?
Oh, I'm sorry. Let me see. I can't get back to the Zoom. Let me stop that and let me try again.
There we go. Great.
If we click on that, we get a chronological list of all the accidents in 2006. I'm going to click to the second page, which means I think I'll have to share it again, but hold on a second. And if I scroll down now, I'm coming to one that I hope you will remember. And it's this one. On the 29th of September 2006, a Boeing 737 took off in Brazil and collided with an Embraer executive jet piloted by a couple of Americans that it was being delivered from Embraer to the United States. And if you click on any accident like this one, the GOAL accident, what happens is it opens up a page of details. And again, I have to.
No, we see it now. We see it.
Oh, you see it now? Oh,
yes. If you stay on the
let me
same
do.
site, we still see it. Yeah.
Okay, I'm going to go back to that page.
Great, thank you.
And so if you look at this, it tells you the date, the type of plane, how many people. There were 6 crew and 148 passengers. All of them died. The plane was destroyed. And down below, it gives a narrative of what happened. And most crucially, because this is an investigation that was complete, it gives the probable cause. For example, here, human factors. This is the registration for the 737 passenger jet. And the crew there were no failures by the crew. What happened was that the Embraer jet, which only had a couple of pilots in it, and that's this registration, they collided and hit the wing of the 737, causing the crash. And if we scroll right down to the bottom, I mean, it gives all the different factors that caused this crash. And right at the bottom, you find a link to the final report. If we click on that, it'll give you the report by the Brazilian authorities, the final report. And notice that this investigation took 2 years and 2 months before that final report was issued. And that's fairly typical of aviation accidents. You rarely get anything at all before a year has passed, because of course, when a plane crashes and there are a lot of fatalities, it is very, very difficult to sift through the wreckage and find out what really happened. But now let's get back to the MAX accident. So on October 29th in 2018, almost exactly 2 years ago, the first MAX crash happened in Indonesia. And within a week, we knew that something was very different. I've been reporting on aviation and Boeing for 18 years. I count myself very lucky. I've never had to go to a crash site. There hasn't been one in the United States in the last 10 years, and no Boeing aircraft has crashed in the United States in all the time I've been working. And when crashes happened overseas, normally they were older planes. Typically it was very bad weather, and often a not very good airline, perhaps. But then sometimes accidents happen and they're very different, like that GOAL accident. And the Indonesian crash, within a week, we knew something was completely different about this one, because Boeing issued what's called a service bulletin to all the pilots in the world flying the 737 MAX, telling them that what seemed to have happened was that a new system on the plane had been forcing the nose down and had been acting repeatedly through the entire 12 minutes of the flight. Boeing didn't, in that notice, tell us what the system was called. We didn't learn that until later. But as soon as they said that, as soon as that bulletin was issued, 1 week, it was actually 6 days after the crash, every aviation reporter in the world knew that this was different. There was something wrong with the plane, and this was a new plane. It was not only, I mean, it was just the plane that crashed was out of the factory just 1 month. It was a 1 month old plane. But the MAX itself had only entered service the previous year. There weren't that many flying, about just over 400 of them. And now Boeing was essentially admitting right away that there was something wrong with the plane. And so, of course, it became my job and the job of every aviation journalist to try to figure out what is it that was wrong. I'm going to share my screen again to show you a diagram that we published in one of our stories. But first, I'm going to have to go to it. Here it is. Now let's. The system that Boeing didn't name in that first bulletin was called MCAS, Maneuvering Characteristics Augmentation System. And this is a system that is designed to push the nose of the plane down if it's pointed up too much. There's a little sensor right here on the side of the plane, on the side of the nose of the plane. It's called an angle of attack sensor. And that tells the flight computer whether the plane is nose up or nose down or nose level. And if it gets too nose up, a plane will stall and fall out of the sky. So this system was put in to push the nose back down. And it does that by swiveling this part of the horizontal tail. The horizontal tail actually moves and swivels around, and that's the air on that pushes the tail up and the nose down. And now I'm going to share something else. Can you see this?
Yes.
No, you can't see what I want to share. I'm going to show you. Now this will look extremely complicated, but it tells a very startling story. And let me begin by saying that when I first saw this chart, which was released by the Indonesian authorities 1 month after the accident in their interim preliminary report. And this is the data that comes from the black box. And I'm not an engineer, and this meant nothing to me when I first saw it. So I needed engineers to explain to me, what is this? And what it actually tells is a very tragic and graphic story. I'm not going to explain the whole thing, but just the most important lines. First of all, this blue line at the bottom is the altitude of the plane. And you can see that it took off at this point, and it rose and then fell about 600 feet, and then rose again up to 5,000 feet. Now I want you to look at this line, this brownish line. This is a line that shows the position of the flaps on the wings. If you look out the window when you're taking off or landing in an airplane, you notice these parts of the wings that extend out the back. That's to make the wing area bigger and provide more lift. But once the plane gets up in the air, the pilot retracts those flaps and they go inside the wing. This shows that at this point, the pilot retracted the flaps, and that's the moment when it lost altitude. The pilot put the flaps back out again. He extended them. That's here. and the plane rose up to 5,000 feet. And then at that level, the pilot once again retracted the flaps as he would normally do as he gets up to a height. Now, here's, this is when the system called MCAS kicked in. MCAS was a software program that only kicked in when he retracted the flaps. And this line right here, this purplish line, shows MCAS, because what MCAS is doing, it is moving the stabilizer uncommanded by the pilot, and it's putting in the plane nose down. So this and this were the first times that MCAS acted. Below this line is nose down, above this line is nose up. These are uncommanded, automatic software program telling the plane to go nose down. In each case, the pilot responded. Now look at the top line, the blue line. This is the pilot's commands, and these are nose up above the line. So in response to these two sudden nose down commands, the pilot responded and pulled back up again. MCAS, he lost some altitude, he retracted the flaps, he extended the flaps again, and he rose up to this height, and then he again withdrew the flaps. And now look at this line. More than 20 times the system kicked in again, and more than 20 times it pushed the nose down. Each of those occasions is a sharp nose down on the plane. And look what the pilot does. Up above, these are his reactions. Each time this happens, he's pulling it back up again. But after about 20 times, the pilot, we think, the pilot had the flu that morning. We think he got tired and he handed to the co-pilot. And the co-pilot didn't respond as aggressively. He wasn't as experienced a pilot. You can see here, he did give a couple of nose up. He's using a little thumb switch on the control column, but he didn't give these strong nose up commands that the pilot did. He gave very short ones. And as a result, the nose down commands took over and the plane plunged into the sea. What you see in this period here, from here to here, this is the altitude of the plane. And you can see it's going up and down as the plane is going nose down and nose up, nose down and nose up. This was the roller coaster ride that those passengers were experiencing until this moment when the co-pilot lost control and it plunged into the sea. So I didn't learn all that right away. And I'm sorry if that seems very technical. We'll not get any more technical than that. But I just wanted to explain that this was a new system on the plane that had been badly designed. And Boeing was giving out very little information about it. They eventually told us the name of it. But we had to find out, why did this happen? Why did the system respond like this? What's going on here? I talked to my sources within Boeing and within the FAA. The FAA, the Federal Aviation Administration, which certifies the safety of airplanes and oversees Boeing and had certified the MAX safe. The FAA unit that does that for commercial aviation is based here in Seattle. And so I have sources within the FAA, I have sources within Boeing. I talked to them, I began to explore around the edges of what had happened here. And the first thing that I came to realize is that a lot of people within the FAA had never heard of MCAS until after the crash. managers at the FAA who were responsible for certifying the MAX had walked into the office after the bulletin came out and said, "What's MCAS?" Asking the engineers, and the engineers, very few of them knew. And then as I talked to people, some more information came out, and one particular thing grabbed my attention. An FAA engineer who wasn't directly involved, but who knew what had happened, told me that there was a number in the bulletin that Boeing had issued that told you how much authority this software system had to move the tail of the plane. And he said that number was different than in the documents they gave the FAA. That number, the FAA documents, the system safety assessment, gave much less authority to the system to move the tail than Boeing was now saying after the accident. And of course, that seemed enormously important. Had the plane been certified with false technical information? But I couldn't write that. I first heard that in January. So the accident had happened at the very end of October. And in January of 2019, I first heard that. But I couldn't write it because the person who told me this didn't have direct knowledge. So I had to talk to other people and ask those people, did they know somebody who had direct knowledge? And eventually I was talking to a couple of people within the FAA. But I felt that this information was so explosive that I needed to see the documents, that I could not rely on somebody just telling me. And that proved very difficult. But one of the tools that is now at our disposal is a wonderful new tool called Signal. I'm sure you're all familiar with it. And I found that Signal is a terrific way to convince people that it is safe to share something, because they don't have to send me a document even. They can take a picture with their phone of a computer screen with the document on it and send it to me via Signal. That's what they did. And they sent me this document, which was the system safety assessment for the MAX. And sure enough, there it was in black and white. And it was a very, very technical document. And again, I'm not an engineer. So I needed somebody to interpret it for me. So I had to meet these people who sent it to me. I met them in a secret location, and they, of course, would be fired for talking with me if it were known. And so I met with them. At this stage, I had printed out the stuff they'd sent me on Signal, and they went over it all bit by bit to explain what the numbers meant. Because the system safety assessment, Boeing has to do a very detailed analysis of the probability of something going wrong. And if A goes wrong, how does that affect B? And how does that affect C? And what are all the probabilities of a fatal crash? Well, as it turned out, Boeing had changed the system very late in the certification process. When the plane was being flight tested, they found another problem with it, and they needed to change the system. And they did change it, and they made it more powerful, but they didn't send the update to the FAA. So almost nobody in the FAA was aware of it. FAA pilots were aware of it, but all the information was very fragmented. And the FAA really had no way of understanding the importance of this system. So I prepared a story that said not only that, but which also identified all the design flaws Now, actually quite early in January or so, Boeing had said they were going to fix MCAS. And they outlined how they were going to fix it. They were going, the system had been triggered by that single sensor. So they were going to make sure there were 2 sensors instead of 1. And it had, as you saw in that diagram, it had activated repeatedly more than 20 times to bring down the Lion Air plane. And they were going to make sure it would only activate once. And it acted so powerfully that the pilot couldn't counteract by just pulling back on the control column, which was what a pilot instinctively does to pull the nose up. And again, they were going to reduce its power to make sure the pilot could always overcome it. Boeing, when they announced these fixes, refused to say that these were flaws. They refused to say that there was anything wrong with the system. They were just making it better. But to me, and I have to say very disappointingly, to this day, Boeing still won't admit that these are flaws. They won't use that word. But they were going to fix them. And to me, these were glaring flaws. And to every, I have many sources within Boeing and many sources of people who've retired from Boeing. And all of them were totally appalled that a system would be designed the way this one was, to be triggered for such a powerful system that could bring down an airplane, to be triggered by one faulty sensor. I mean, this little device on the side of the nose of the plane that told you whether the nose was up or down, it was faulty. And that one system being wrong brought the whole plane down. So how could, it is a fundamental part of our engineering, aerospace engineering, that there's multiple redundancies. You do not design something so that one failure can bring the entire plane down. So how could that not be a flaw? It was just ridiculous not to admit it. Anyway, I gathered all this information. It took some months, and we put together a story, and I sent it to Boeing. I sent all the details to Boeing on March 4th of 2019, and I asked for their comment. I told them about, we're going to state what all these flaws are, these 3 different flaws in your design, and we're going to talk about the certification of the airplane and the number being different in your system safety assessment than actually was on the plane. And I gave Boeing, I told Boeing we're going to publish on Sunday, the 17th of March. So that was on the 4th. I think that was maybe a Wednesday or a Thursday. And I wanted to give them time to get back to me. But on March 10th, I was awakened by my editor to tell me that the second plane had gone down. Now that was, of course, a very great shock to everyone. We had a news meeting the following Monday morning. And the first point of discussion was, are we going to run our story on Sunday? And initially I argued that maybe we shouldn't, because we had no idea what caused the second crash. This was the day after the second crash in Ethiopia. And I said, well, look, if we publish this on Sunday and we talk about these flaws in MCAS, people are going to think that's what caused the second crash, but we don't know that yet. So the editors basically said, look, work on it this week and see if we can find out anything about the Ethiopian crash. And we did. And by this time, a small team of people had been appointed to help me out. And they used social media and LinkedIn to call flight control engineers, to identify Boeing flight control engineers and FAA people, and just made cold calls and made some good connections. But basically the news came out of Ethiopia within days that the flight pattern looked very similar. And then I remember on the Thursday, I was interviewing a safety consultant who's very well known in the United States, an air safety consultant called John Cox. And as I mentioned, these investigations, these official investigations normally take a year before you hear anything. And the international protocol is that the investigators are not allowed to talk about it. Boeing is helping the NTS, the National Transportation Safety Board of the United States is helping the Indonesians and the Ethiopians because they made the plane. But they're not allowed to say anything officially. But I was talking to Cox and asking him what he knew, and he mentioned to me a detail that he had heard from investigators on the ground in Ethiopia. And as soon as he said what it was, I knew it was important. And I knew only because of a previous aviation accident. He told me that the jack screw of the plane had been found in the wreckage. Now the jack screw is a giant screw in the tail of the plane that moves and swivels the horizontal tail. And I knew that only because there is in Seattle a crash that is seared into the imagination of everybody here. In 2000, Alaska Airlines Flight 261 crashed into the sea on the way back from Mexico to Seattle, killing everybody on board. And that crash famously was caused by the fact that the jack screw broke. It had not been properly maintained. And everyone, certainly everyone in the aviation world here in Seattle knew that. As soon as Cox said to me they'd found the jack screw, and the crucial detail he told me was they found the jack screw and it was in the horizontal tail was in the full nose down position. And actually you could tell that by looking at the crash site. The Ethiopian crash site was just a hole in the ground. It was very clear the plane had gone nose first into the ground. So with the flight pattern, the up and down flight pattern, and the knowledge that the horizontal tail had been moved to full nose down, we decided that there was enough similarity that in fact they did look like the same problem, and we ran the story. So the Ethiopian crash had happened on a Sunday. We ran the story the following Sunday. In the story, I told readers we gave this information to Boeing 6 days before the Ethiopian crash. And of course, that had a tremendous impact on people, and readers all over the world contacted me after the story, and TV stations and whatever, because we seemed to have identified so quickly what had happened in the second crash, but in fact, it was all based on reporting of the first crash. That was the beginning of our work. That story had a huge impact, and we followed it up with. It brought in all the national press. The New York Times, strangely, the New York Times doesn't have an aerospace reporter. They have airline reporters, but they don't have anybody who works on manufacturing of airplanes. But they appointed a team of 3 people, of absolutely star reporters who immediately became experts and gave us great competition. The Wall Street Journal also has a wonderful aviation aerospace reporting team. So there was a lot of competition, and we were all trying to work out more of what had gone wrong. One thing that appalled readers about that first story is many people who aren't in the aviation business didn't realize that when the FAA certifies an airplane, a commercial jet, it's actually Boeing that does the work. Boeing engineers working on behalf of the FAA, but paid by Boeing. They do the work. And this was news to a lot of people. And of course, they were appalled that the oversight had lapsed so badly in this case that these glaring flaws had been missed. We followed up with many, many more stories. For example, within a month of that, we were explaining what had happened on the Ethiopian crash. Because it soon came out that after the first crash, Boeing issued that service bulletin to tell pilots this system could be pushing the nose down. It could go wrong in certain circumstances. So this is what's happening. And they told pilots what to do if this happened. They told pilots there's a simple procedure. You basically end up hitting a cutoff switch, and that will cut all power to the tail, and then it will stop. And when we examined what had happened on the Ethiopian crash, it became clear that the Ethiopian pilots, unlike the Lion Air pilots, had never heard of MCAS because Boeing had told nobody about it in advance. But the Ethiopian pilots knew about the Lion Air crash. And it became clear that they had done what, or tried to do what Boeing suggested. They hit the, I could show you a similar diagram to the one I showed you with all the lines on it for the Ethiopian crash. And that reveals that they did hit the cutoff switches. They did cut power to the tail. It did stop MCAS. But then it didn't work because at the moment when they cut the power to the tail, the stabilizer was in a steep nose down position. And the next step they were supposed to do was to take a wheel. There's a wheel in the cockpit, and they were supposed to turn that and manually move the wheel. Let me show you what it looks like. Hold on a second. Okay, I'm going to show you now. So this black wheel is at the hand of the pilot, and there's a little handle on it, and he can turn that to swivel the tail. And that's what Boeing said they had to do: cut power cut the electrical power to the tail and move this wheel manually. So we had to figure out why didn't that work. And in the cockpit voice recorder, you can hear the flight. You can read how the co-pilot told the captain, "I can't move it. It wasn't working." And the reason he couldn't move it, is that the forces on the tail were too strong. The captain was pulling back on the control column, which creates a nose up effect by moving a little tab at the back of the tail. But the stabilizer was already in a nose down position. And the forces on the two created a kind of jam. The tail was jammed, and the pilots couldn't move it. So what they then did was, because they were obviously desperate, they switched the system back on, the electrical system to the tail, in order to try to move the stabilizer, the horizontal tail. And unfortunately, that immediately activated MCAS all over again, and it pushed the nose down, and they went into the ground. But I had a story explaining the mechanics of that. Yeah, let me just also share that again. This is the story, why Boeing's emergency directions may have failed to save the MAX. This is in the Ethiopian crash. We published this in April, so it was a month after the crash. And we did this diagram to explain, this is the horizontal tail and how It creates an upward force that could push the nose down, or a downward force that could keep the nose up. And we explained the various forces on it when the captain was pulling this little part with the control column and making it jam. So, right, back to me. Another thing, another scoop that we got in the course of our investigation, one of the reporters who'd been assigned to work with me was a guy called Steve Militich. And Steve was an expert in legal proceedings. In fact, he had covered the lawsuits that followed the crash of the Alaska Airlines Flight 261 20 years ago. And Steve was brought in to help me, and he had a lot of legal sources. And through a legal source, we heard a whisper that there was an internal complaint within Boeing. An internal complaint by a flight controls engineer arguing that during development of the MAX, they had declined to put some improvements on the plane that might have prevented the crashes. And thanks to that tip that Steve got, we eventually, I can't say how, but we eventually got hold of that internal complaint and we published it. And that was a window into the world inside Boeing, where one engineer was trying to argue we need to add this safety, this new system. And the managers at Boeing were saying, no, we're not going to, because we don't want this plane to be very different from the previous model. It will add cost, it will add a lot of problems for the airlines. They'll have to train their pilots differently if we put a lot of new stuff on this. So minimal changes. And our reporting came to this a lot. Revelations from inside Boeing and inside the FAA that Boeing's development of this jet was constantly curtailed by an imperative from management. This plane cannot be very different. Southwest Airlines wants this plane to be exactly like the previous model, except it'll have bigger engines, it'll be more efficient, but we want it to be just like the previous model. And Boeing had actually, when Southwest Airlines is the biggest 737 customer in the world and was the launch customer for the MAX. And so when they made their big order of more than 100 planes, they wrote into the contract that if the pilots required extra training in a simulator, Boeing would pay Southwest $1 million per airplane. So it was Boeing management's imperative that there should be no simulator training. It had to be something that was so like the old model that pilots would do a 2-hour training on an iPad. That would be all they'd have to do to satisfy airlines and cut their expense and make it attractive to the airline. Oh dear, I'm way over my time, am I not?
Yeah.
I should stop.
Tenemos algunas preguntas. We have some questions, and I have a couple for you. I would like to start with maybe, can you give some suggestions of some of the sources that you cultivated? You mentioned several of them. You mentioned attorneys. You mentioned current and former engineers. You mentioned how the investigative team that worked with you used LinkedIn and social media to find other circles of people. Do you have other suggestions about ways to develop a kind of a group of experts that can help you interpret something on the fly? Entonces la pregunta mía es, ¿cuáles son algunas sugerencias de cómo desarrollar y cultivar fuentes en esta área tan especializada de adentro o de fuera de una compañía como Boeing?
Well, first of all, I should say that covering Boeing, I feel very, very lucky. It's very different covering a company like Boeing compared to, say, Microsoft or Amazon, because Boeing is it's an older company and it has lots of different strata of people that work there. So I get to talk to the executives and the CEO, but I also get to talk to the engineers, these white collar guys, and I get to talk to the guys who build the planes, these blue collar guys, and everybody in between. And crucially, it's a unionized company. So the blue collar guys are unionized, and so are the engineers. Unions are wonderful sources for not even the union leadership, but the members of unions are always good sources. The FAA is also unionized. The engineers who work inside the FAA, who certify these planes, they're unionized. And when you have a union within a company like Boeing or within an agency like the FAA, frequently they're at loggerheads with management. And the unions at Boeing have been at loggerheads with management for many, many, many years because management has treated people here pretty badly. Outsourced work, sent work away, taken away pensions, laid people off. So there's a lot of people willing to talk and tell you what they think of management and to help you out in any way you can. So in many ways, it's an easier beat than most to get sources. And as I said, it's not only within Boeing, it's within the FAA. You'll find that the safety engineers within the FAA aren't happy with FAA administrators in Washington, DC, who sometimes seem to see their job as helping the industry compete against Airbus and getting out of Boeing's way. Whereas the safety engineers, they see their job as safety. It's my job to certify this as safe.
We have another question. I'm sorry, go ahead.
Sorry, go ahead.
We have another question from Liliana Corona. She says, ¿qué hizo Boeing para evitar que publicara esta historia? Did you have any pressure from Boeing either to not publish or to retract any part of the story once you were published? Did you face
nothing? No. You know, as I said, I gave Boeing the information that was going to be in that first story 6 days before the second crash. And then we published a week after the second crash. They got back to us with a minimal statement saying they were sorry for the tragedy, basically, and nothing else. They didn't question anything, and everything we wrote has been verified ever since.
And you said that you divulged sort of a
Boeing's never admitted fault.
You said you divulged sort of a summary of what you were going to report, right? In addition to asking questions. Is that correct?
Yeah, I told them the detail. We're going to say this about this design, that this is a flaw, this is a flaw, this is a flaw. We're going to say that about the certification, that you put in a number there that turned out to be different than the actual number. I told them all the details and asked for comment. But no, they never questioned any of the reporting.
I think that's a really interesting point, that you not only sent them the questions in advance, but you disclosed some of your findings on a very competitive national story because of the nature of, I think, the findings.
Well, it was necessary because this is a very sensitive story. We're saying 346 people died, and we're pointing to why. We have to give Boeing we have to tell them this is what we believe to be true, and if you think different, then tell us.
Yo creo que es muy importante la ética de la decisión de publicar, la ética de informar Boeing de antes de publicar de la lista de alascos de los reporteros. We have another question. Kind of looking forward to what are some of the other stories that you might do on the 737 MAX? This issue of training, is that still up in the air? What are other sources or other stories that are still pending? ¿Cuáles son algunas más fuentes y pistas para los que quieren seguir cubriendo esta historia? Es una pregunta de Freddy Pimentel.
Well, just within the last month, the FAA, the Federal Aviation Administration, issued 2 reports, one describing the update to the systems in the airplane, which they now think will make it safe. And secondly, a report on what pilot training will be required. It is expected that they will finalize. They asked for public comments on both of those, and the comment on the training just closed a week ago. It's expected that the FAA will approve the plane to fly again, possibly towards the end of this month or else next month. More likely at this point, I think next month, because the comments from the pilot unions on the training that was proposed were extremely detailed. And I think it's going to take Boeing a while. It's going to take the FAA a while to process the various comments that were made and decide what to do about each one. However, I still expect that by the end of the year, they will approve the plane to fly and the pilot training will be finalized. And that means it will be flying in the United States in early January.
Entonces él está pensando que este avión ya va a estar otra vez aprobada ya en enero. Una pregunta más acerca de, ya mencionaste la importancia de sindicatos de los ingenieros y los obreros adentro de Boeing y también adentro del gobierno federal, pero además veo que en el reportaje usaste bastante los pilotos y el sindicato de los pilotos. Yo creo que es un recurso importante para todos. Can you talk a little bit about the importance of tapping the pilot unions, either both nationally in the United States or internationally, for sources? Because it seems that that was also an important source for your story and one that could be useful for others on this chat today.
Sure. I mean, the pilots were talking to pilots around the world was very useful, first of all, in understanding everything, understanding how these systems work, what it means to a pilot, but also, I mean, US pilots were very upset when they discovered this system because no pilots anywhere in the world had been told about it. So one of the early things that happened was that Boeing sent an executive to Dallas to talk to the American Airlines executives, and he met with the American Airlines pilot union. And he, in closed doors, talked to them and explained what this system was and told them they'd be able to handle it no problem. But that meeting did not go well. They were very angry at him. They wanted to know why they hadn't been told about the system. And as a result of their anger, they leaked an audio of that meeting to the press, including to me. And so that helped bring out to the public to understand that the pilots, I mean, somewhere in the United States, we're of course pointing to Indonesia and Ethiopia and saying, oh, well, no, foreign pilots, probably not very well trained. But the American pilots in US airlines were saying, no way, this is a system we should have been told about. And so I had various pilots going on the record in stories, severely critical of the system, severely critical of Boeing. And it was very useful to my understanding and useful to moving forward the whole discussion.
And on that note, the leak of the audio was something I wanted to know if you could talk about. You spoke earlier about screenshotting something and getting a screenshot and then a signal message to keep from having kind of an electronic record. of who might have leaked something to you that would have been dangerous to their job. In the case of the pilots, I suppose they weren't running that same risk of being fired, but can you talk about how you got the audio? Y voy a traducir la pregunta. La pregunta es, él ya mencionó que usaba ellos el equipo Signal para pedir a una fuente de dentro del gobierno federal de sacar la pantalla de una base de datos de secreto del gobierno que era importante para la investigación principal de básicamente sobre la diferencia en la información presentada al gobierno federal a la hora de probar el avión comparado a la información dada por Boeing después del choque de la aeronave. Y luego, cuando encontró este audio clave de pilotos, estoy preguntando cómo manejó el audio para proteger la fuente. Sorry, long translation.
Well, I wasn't the first to get that audio. I think it might have been a Dallas newspaper, the Dallas Morning News, that first got it. They're very close to American Airlines, report on it a lot. So once I saw that, I simply contacted American Airlines pilots that I know and asked them, and they sent it. They didn't use Signal, they just used email. It wasn't hard to get. They wanted it to get out. I think it was an unofficial tape recording, mind you. I don't think the Boeing guys knew about it. And by the way, I should mention, I said the international protocol doesn't allow Boeing and the FAA to officially say anything. But that same executive who went and briefed the American Airlines pilots, he also gave private briefings to various journalists in the United States, including me. And it was all on the basis that you can't attribute this to a named Boeing executive, but they wanted to give their side of the story and give their explanation for the system and why they thought it was okay. So, I mean, that was useful to have that, and we reported that. I remember in the end, we did a really big analysis of how this system called MCAS had been developed from the beginning, from the wind tunnel testing, and why it had changed and what the impact of that change was. And I got a briefing at the Paris Air Show from that Boeing executive that we basically knew most of it, but I was able to have like 90 minutes with this guy and ask him about all the details that we knew and get his version of events. Mm-hmm. And that was very, very useful. And I actually had to leave. I go to the European air shows every year for the newspaper. It's Paris Air Show one year and the London Farnborough Air Show the next year. And it's usually a big deal to cover the Paris Air Show. It's a very intensive week. But I remember I interviewed him on a Wednesday late in the day in the middle of the Paris Air Show week. And after that, I just had to leave the air show. I left the air show, went back to my hotel, and I just wrote for 2 days. I didn't see anybody else at the air show, and published on the Sunday this long detailed feature on exactly how MCAS had been developed.
Thank you very much. That's really interesting. I think we're at the 3 o'clock mark, but yeah, I learned a lot, and I think it was a great session. Thank you so much, Dominic.
Oh, well, thank you. I appreciate it. Bye.
Ciao.
Ciao.